I'll keep today pretty short and to the point, hopefully. Just on commercial energy efficiency options within code, and look ahead to future code cycles. The screen starts working. John, I know you're part of ASHRAE. Dan, you might be as well. Just a reminder that tomorrow there's a lecture here downtown at our office with Amanda Bonier on fully leveraging your energy model. And free lunch, so register for that if you haven't already, because I think it will be very relevant to half of what I'm talking about today, which is if you're not doing energy modeling yet, it can be a big help in terms of code compliance. It's not worth it for every building, but there are ways that it can potentially save you some headaches of going through all the different HVAC pages that you need to for the 2018 and 2021 IECC. So I'll email out CEUs to folks that are attending. Let me know if, in addition to just the standard AIA or professional development you need for engineering, you also need code IGC credits. So this can also be applied for that. But basically, we'll talk about how to use energy models to meet the requirements of 2018, and then look at design flexibility with some of the different options, the menu of options, and which ones are best for specifically Idaho and Boise and buildings in Climate Zone 5B, and then a little bit on economics. So the two sections of the 2018 code, which is currently required in Idaho, and it's pretty much word for word in Idaho with the 2018. For residential, there's some amendments, but typically Idaho code just passes. The commercial kind of carries through without too many extra amendments, which cuts down on language and state amendments, which is generally a priority of the DOPL, the Department of Occupational and Professional Licenses, who sets these standards for Idaho. And I'm just looking at the two sections at the end of this code, which is additional efficiency options and then total building performance. And like I said, I'll try to keep this pretty tight, 30 to 45 minutes. But if you have questions, it's a small crew. Interrupt anytime, type something into the chat, and let me know if you want to dive deeper into any particular topic. And if I don't know or I don't have it at top of mind right now, feel free to email me afterwards or still put it in the chat, and I will do the work and research to get an answer to you later. All right, so for 406. This is Idaho code right now. You have to choose at least one. So they give you 7 different options, but to pass minimum energy efficiency code, you not only have to comply with everything that came before, you also have to choose one thing that would be above code to meet code. You have to go beyond in one particular area. So that could be more efficient HVAC, better lights, adding renewables, using a DOS, having better water heating or a better envelope. So just talking about more efficient HVAC, looks like we've got a lot of mechanicals on here. You're just going 10% better efficiency over minimum. And that applies to your AC units, your heat pumps, your PTACs, your furnaces, boilers, condensers, chillers. If it's not on that list, for example, it doesn't mention electric resistance heaters, then you can still have those in your project and achieve this credit. But those components that are not on the list, which are listed there, can make up no more than 10% of the heating and cooling capacity or load design for that building. And you're trying to get, sorry, fire hydrant outside office. You're trying to get all pieces of equipment to exceed that minimum efficiency by 10%. So you can't just say, well, I've got a really efficient chiller, therefore I meet this requirement. If you want to achieve this efficiency credit, all of your HVAC has to meet this. And VRFs have a particular call out where they're looking at the ASHRAE 90.1 requirements, because those aren't listed in the C403.3 tables. So an example, my computer will work. There we go. You know, if you've got a 300,000 BTU per hour gas boiler, according to code, you've got an 80% minimum efficiency requirement. Doesn't mean they have to jump up to 90%. It just means 10% above the minimum efficiency. So 10% of 80%, 8%. Another example is, you know, you've got an air conditioner going from an 11 EER to a 12.1 EER. Basically just do 10% better in order to achieve that optional efficiency credit. And once again, that's just one of 7 options. The next one, this is where you have to talk to your electrical pals, is reduced lighting power. And if there's one option that is easy on here, this is the one. So if you are just trying to get this project done and meet the minimum requirements, the one option off of this list that's pretty easy to do is to just do reduced lighting power. It's not controls, we'll get into that next. It's just you are installing light wattage that is 10% below the total allowance. So either the lights are 10% more efficient, or you just find a way to get the lumens that you need with fewer watts in the building, maybe fewer fixtures, but you're still getting that required illumination out of it. So LEDs have become so efficient that the total allowance in the code right now is much higher than what might just be typically specified. So this is an easy win for you if you're trying to meet minimum energy efficiency code for Idaho. So for example, we've got a 52,000 square foot warehouse. You look in the table, it's based on building type for the total lighting allowance, and that was 0.48 watts per square foot. So you're allowed 25 kilowatts of lights that are installed. And if instead you find the right fixtures that work for your building and you install only 22.5 kilowatts, sorry, our office is next to St. Luke's, so we get a lot of sirens going by. You can hear that in the background. Anyway, rattles my brain a bit. But if you install just 22.5 kilowatts of lights, then you meet that efficiency requirement, right? Pretty easy to calculate. Shows up on CommCheck. As long as you're still providing, you know, the warehouse illumination requirement, which is 30 lumens per square foot. The other option you can do on the lighting front is enhanced controls. So this is, you have to comply with all of these points. You have to have continuous dimming. Each light, they call it luminaire, is individually addressable. So you can control each one, not that every single one is on its own controller, it just has the option to be controlled. And if you have a daylight zone, you can have no more than 8 of those fixtures tied into one photocell. It also requires digital controls. It requires a sequence of operations to be included in the construction documents, and it requires the lighting control system to be commissioned. So compared to what we were just looking at in terms of reduced lighting power, far more strict just for that one other option, that one efficiency credit. The other way to what the code is trying to do, why it's having all of this at once, is it's trying to push you to install what's called luminaire level lighting controls. The luminaire level lighting control system is going to meet all of these requirements. Just notice that there's a chat. Yeah, how much, so question from Dan, how are lighting controls looked at for saving energy and how much savings are attributed? That is a good question, because it depends on if you're looking at occupancy controls or if you're looking at daylight dimming, and then individual zoning of the spaces and optional dimming. There's different percentages associated with each one if you're doing an energy model, and LEED and 90.1 will lay out some of that. I think it's about a 10% reduction for occupancy. University of Washington has been doing some interesting studies where they're measuring actual savings of pre-luminaire level lighting controls and post-luminaire level lighting controls. And I think they were seeing close to 25% lighting power savings, which was a combination of occupancy, dimming, all the things that are on here.
Damon, I appreciate it. It's always hard because when you talk about lighting controls, they can be very aggressive and they could be a sequence of operations showing extreme savings, but I'm not sure how they allow that and how they verify that type of thing. And it seemed to be always a kind of a gray area and not very well set. So I appreciate any information. Thanks.
Sure. Yeah. I will say, we've heard in testimony to Division of Building Safety that the more complicated the controls get, right, the sooner the facility manager is just going to unplug the thing, right? And then you're not getting any of the savings. So the idea actually is, instead of abiding by all the requirements, and my colleague Dylan Agnes, he's the specialist on lighting efficiency here. But if you look through the lighting sections in the code, it's pretty long, it's pretty intense, it's a lot of calculations, depends on like window overhangs and everything like that. And it can be a headache to design it all. So one way of kind of getting around some of those controls is to just use luminaire level lighting controls, where every single one is smart. It's on its own power over Ethernet network. And we've got them installed here in our office. So if you come to the ASHRAE lecture tomorrow, or if you ever just want to stop by, we can show you how we use them. So on my phone, I can control the fixtures just around my desk. Got one remote switch, but you can also just log into a web page and address each one. And it can the idea is to make it more streamlined and simpler. So rather than like all of these different controls all over the place that occupants are going to play with or get angry at, you give all the control in a simple interface. Maybe it's just a remote wall switch to the facility manager. And so that's what they're trying to move towards. It's if you were to do this in a way that's not using luminaire level lighting controls, I think it would be a challenge and expensive. And luminaire level lighting controls, even on their own, they can be expensive. You're paying more on hardware, but less on controls because the sensors are already built in. So there's less wiring that needs to be done. And yeah, like I said, there's resources out there from University of Washington, Northwest Energy Efficiency Alliance on installing them. And yeah, very high incentives from Idaho Power available for LLCs, and Dylan here at our office can help you for free if you have a project that's interested in this. So because they see it as a potential of saving lighting power. But like the lighting savings are getting smaller and smaller, right? Because now we've got LEDs rather than incandescents or fluorescents, and so we're using fewer watts. And so trying to like squeeze more blood out of the turnip on the lighting front is getting challenging. All right. Another efficiency option available is on-site renewable energy. And that's either 3% of most of the building energy, not necessarily all of it. So if you've got, you don't have to worry about plug loads or a data center in there, but 3% of the building energy that's used for HVAC, water heating, and lighting. If you install that many solar panels, that many kilowatts, then you meet that credit. Or the other option is 0.5 watts per square foot of conditioned building area. In Boise, we also have access to geothermal, which not many places do. So if you do hook up your building to geothermal, as long as it provides 1.7 BTU per hour per square foot, which you easily get out of the geothermal, then you would meet this on-site renewable energy credit. Something specific to Boise that might be helpful. And I know City of Boise is trying to expand their geothermal network, although it's not always easy due to the backup systems that are occasionally needed. Slides are struggling to advance. Okay. The other efficiency option, very relevant to mechanical engineers, is just specify a dedicated outdoor air system, where you're separating your ventilation from your heating. So that could be a VRF, heat pump, even a radiant system or chilled beams in the space. Any building that's using a DOS, you automatically meet an additional efficiency option, so you don't have to worry about the rest of the list, right? They're really trying to encourage this in code, and then you've got states like Washington, where DOS is already required for a lot of their municipal buildings and things like schools. So if you have one of those projects, you're already set on this list. The other efficiency option, this is 5 of 7, sorry, still have a couple more to go, is high efficiency water heating. So you can do waste heat recovery from your service hot water or some sort of heat recovery off of your chillers. There was that great presentation, Ashray from that distinguished lecture a couple of months ago on chiller heat recovery. And then process equipment. If you're recovering some heat from that, that's great. It doesn't necessarily apply to offices, though. This only applies to buildings that meet residential, healthcare, restaurants, or where the hot water load is 10% of the building energy. Or you could also use on-site renewable energy for hot water. Although solar thermal, we have yet to really see it applied a lot in our area. Takes, in terms of the infrastructure to install it, it's rare that it pencils out. This one's more for the architects, but definitely affects heating and cooling load calculations. You can meet your additional efficiency requirement by using an enhanced thermal envelope. So that's a 15% improvement of the total UA over the tables that are given earlier. So you're looking at the sum of the U factors times the area of the slab, the below grade walls, glazing, and skylights. And you look at that total number for your building that's meeting minimum code. And then if you run your comm check and find out that your UA is lower than that by 15%, then great. You can meet this efficiency credit. It should also be conveyed to the engineers, though, so that we don't oversize our heating and cooling equipment. Question from Rick: does hooking up to a district geothermal service constitute on-site renewable? Yes, I believe it does. It certainly does for Energy Star. If it was just a district hot water system where you've got a district system and a central boiler somewhere else, then no, it doesn't. But geothermal is pretty unique, and I believe that it does count as renewable. But if you get any pushback on that, let me know, and we can provide some backup. But it certainly applies. City of Boise considers it a renewable resource, and it has been eligible to apply for some of the infrastructure funding from the last administration in terms of renewable energy development. Yeah, good question though. All right, the last efficiency option available is reduced air infiltration. And the requirements here are not to do any better than the code minimum for commercial buildings. It's just to test and verify. So the nice thing is, instead of going through the prescriptive checklist of every single component and air barrier and window and sealant, if you test, you automatically meet that infiltration requirement, and you will also get this efficiency credit. So two birds, one stone. The thing is, the buildings that were tested that did not have an envelope consultant on them, I think it was only, I'd have to look at my notes, 10 or 20% of them actually met the requirement. But every single project that had an envelope consultant on it, when they tested, they were like 40% below the air leakage rate. So it's not that hard to do, as long as you've got someone checking in on the process. And this is not only like during the design phase, it's going out to the site kind of during the construction phase, just a couple of times to verify, that the trust, but verify that the contractors are, taping seams, adding in zips, whatever's been specified. We don't do a lot in Boise, as far as I'm aware, blower door testing on commercial facilities. If we go to the 2021 code, it is going to start being required for multifamily units, mixed use. And of course, you can't pressurize, a whole skyscraper, where you could, but that'd be extraordinarily expensive. So for really big buildings, those over 250,000 square feet, you can test just 25% of the building area for air infiltration. And I think this does a service to engineers as well, because you'll get a much better sense of the actual infiltration for the building and whether you need supplemental heat or cooling, because that infiltration is about 35% of the total heating load in the winter in our climate, which is a lot. So if you cut that down by half, I mean, that's changing your heating load by 15%. So I think this is great if you can find a good commissioning agent who will do the testing. There's two different compliance pathways. They're both ASTM standards. I think one uses CO2 and the other just uses pressure gauge. So once again, a way to meet like your just normal envelope requirements for infiltration, so you can skip a lot of the tables and documentation, and a way to get an efficiency credit. So that kind of wraps up section 406. which is you have to choose one of those different options, right? Section 407, the next section, is optional. So you don't have to do this, but it's a way to bypass a lot of the code that came before. You can not ignore, but it's far less documentation from a prescriptive standpoint to go to a performance model. And this is an energy model, right? So I hope the speaker will talk about that a little bit tomorrow for ASHRAE. And this, you're looking at energy costs. And the energy costs must be 15% less than the baseline model. And this relies on ASHRAE 90.1 for the model compliance. It's got a table of like the type of HVAC that you have to put in there based on the occupancy type and the climate zone. And of course, you can't have like, you know, one building with no windows and foam walls, and then your real building, which is like glass everywhere, and you just think, oh, I'll throw in a VRF and it'll be fine. Like the geometry and use must be exactly the same between both models. And the code does provide a map of you know, which HVAC type is provided. And there are still some sections of code, even if you use the performance model, that are still required. The reason they have particular baseline HVAC is because that affects the type of fuel that's going to be used for heating. And they don't want you comparing, say, electric resistance heating versus whatever system you might be using. If instead you might be normally using gas, because the cost difference between gas and electric resistance are significant. So this I pulled up just last week. It's a bit small, but if you squint, you can kind of see. On the left is Idaho Power's basically general service tariff for commercial buildings. And on the right is Intermountain Gas, what they're charging for therm. And the reason that's relevant is, one, you want to build it into your model. And it's not a straight cents rate. I mean, you can, but the code official has the ability to reject it. If you say, well, it's on average 7 cents per kilowatt hour. The code official, it's up to their discretion, but they can require you to put in the actual rate tariffs, right? Which differentiates based on summer or winter. And then, you know, the energy charges vary based on whether it's on peak or off peak. And then you've got different demand charges. The energy model can do all of that. It might be a headache trying to do that if you weren't using an energy model, but this is for energy modeling. But you do have to be careful that you do build in the current rates for it. And the reason that matters is, once again, we're looking at the energy cost. You're trying to save 15% cost, which I think is great for the client. But if we're looking at the dollars, or the cents rather, between per kBTU between electricity and gas, the reason we use a lot of natural gas in Idaho is because it is so darn cheap. It is half a penny per kBTU, whereas electricity is 17 cents per kBTU. You know, these can fluctuate, they can change. And if you are installing or designing a building up in, say, McCall or Ketchum or Salmon, where there is not access to natural gas, then you're looking at a very different comparison, and a place where, yeah, a heat pump is going to make a huge difference over an electric water heater or boiler there. So, so you're looking at energy costs. So be aware of the fuel type that you're using, particularly for heating in our climate zone. And then you can't just say, well, I modeled it and it looks great, so I don't have to do anything else in terms of energy code compliance. There's still some things that are either challenging to model, or are so important to the energy efficiency of the building that the IECC says we're still going to require this. And that is air leakage. So either testing, right, which gets you off the hook for all, the efficiency, extra efficiency option, as well as avoiding the prescriptive requirement. But if you're not doing the testing, then you do have to go through the prescriptive air barriers, list each of their infiltration rates. So air leakage is still required, still have to do that. You still have to use the minimum efficiencies for your heating and cooling equipment. Still have to have economizers, at least in our climate zone. You still have to meet the maximum lighting power density, the watts per square foot that you're using for your lighting. Efficiency in terms of your service water heating, and you still need to do commissioning on the building. A few others that maybe go without saying, but are still required if you're using the performance method, is you still have to calculate loads. You still have to have efficiency options for data centers that are required in the code. Still have to have ventilation and fan controls, ceiling fan efficiency, refrigeration equipment, and make sure you're meeting minimum efficiency on mechanical systems, even if they're outside of the thermal envelope. So those are the two big sections. Looking ahead, what might come down the pipeline if we switch over to 2021, or you're designing an estate that uses IECC 2021, or 2024, which just came out I think it was published in October, maybe September, but it's fairly recent. I don't know any places that have adopted it yet. But let's just start with 2021. So what happens for each of these sections? Idaho, reading the tea leaves right now, I don't know that we will adopt the 2021. It seems that if anything, we would skip a step and adopt the 2024 code, just for consistency of code language. And there's been a push on certain other aspects of, say, fire safety and things outside of the efficiency code, but other parts of the code family where they want it to be more consistent with 2024. And making that leap. So if Idaho does adopt a higher energy efficiency code, I think we might leapfrog 2021, but all the 2021 usually kind of builds into the 2024. And so just looking at, the transitional stages along the way, what happens with each of these. And I don't even know that we will adopt a new code anytime soon. I mean, the earliest would be 2 years from now. And if we do, I think there would be some major amendments specifically to Idaho, where we kind of dial back some of the more stringent aspects of it to make it easier for code compliance, particularly in rural districts. But you want energy efficiency codes to make sense. You want them to be effective and not just full of gobbledygook and not actually saving time or energy. So one thing that changed between 2018 to 2021 in terms of 407, what we were just talking about, the performance method, nothing really changed. They did put a new table in there that makes it clear what's required rather than just referring to just different chapters of code. It's nicely laid out. All the things that I just mentioned, I pulled actually from the 2021 code, because it just puts it in a nice table there. 406, however, that, what's right now is, pick one of these 7 different extra efficiency options. That changes pretty significantly for 2021. And maybe you're already dealing with this if you're dealing with the jurisdiction that's in the 2021 code cycle. Instead of just choosing one of those options, you now have a points-based system. And those points change based on the climate zone where you are. It also adds a few options in there, options that weren't in the first 7. So that adds having an energy management system, having fault detection and diagnostics, a program like SkySpark or some overlay that's going to provide alerts and then potential fixes if, say, your chiller starts to come out of whack and your temperatures are off in your building. Also added efficiency options for kitchen equipment. So it's a very different model, and that changes even more in 2024. So in 2024, IECC, it's instead of a point-based system just based on climate zone, now we've got a new credit-based system that's based on both the climate zone and the building occupancy. And so it gives you a couple of tables. It includes those extra options, like I just mentioned in 2021. 407 also switches, and it switches to a new formula instead of just your performance model where the energy cost has to be 15% less. Now, because there's more efficiency options and some of those have energy cost savings, it's a new formula, which I'll get to on the next slide. And it also adds definitions for jurisdictions that are looking at source energy savings rather than on cost. So code requires looking at cost in 2018 and 2021, but you do have some, say it's government or another jurisdiction where they might be looking at source energy. They're very concerned about carbon. Not something you'd probably see in Idaho, but you do have jurisdictions out there where they're looking at source energy savings for that performance option. And so 2024 adds some extra definitions there. It also adds some definitions for the baseline model, so it updates that baseline model table. Oh, and a comment there from John. Oh, thanks for checking my math. One therm, 29 kilowatt hours, 54 cents a therm. I will go back and check my math. I was going straight from therm to kBTU, with one therm being about 100 kBTU, and so it's dividing 54 cents by that. But I will double check that at the end of this. So thank you, John. Appreciate you checking on me. Okay, so here's the new formula for the percentage annual energy cost savings. It used to be simple. It used to be 15% less. Now we've got to navigate this. The ECR in there is the energy efficiency credits, which are required with the new 406 section. And the new credit system, like I said, so 2018, so just walking through again, just to help my own mind in terms of the linear nature of this. 2018, what we're doing right now, you've got 7 different options of efficiency. Pick one of them. Great. 2021, it's a points-based system based on the climate zone. 2024, it's a credit-based system based on climate zone and occupancy. And you have to have a certain number of credits, and those credits count into this formula for your total performance calculation. It's a bit roundabout. I wish it was simpler. But the credits can be somewhat easy to calculate, and by using the total performance, the energy modeling method, you you can still bypass a lot of other parts of the code and save yourself some headaches there. So what are these energy efficiency credits that you now have to meet in the 2024 code? So just to be aware of if you've got a jurisdiction that's going to switch over to the 2024 code. The requirements, like I said, it depends not only on the climate zone, but it also depends on the building occupancy group. So resident R1, 5B, you need to have 86 credits. And where do you get those credits? They're trying to add flexibility. They're trying to add more options than you had in 2018. But there's a lot of them. And the number of credits, once again, are different between climate zones and occupancy types. So for example, this is looking at R2, R4, and I1 occupancies, and we're in climate zone 5B. You get different amounts of credits if you're using that UA reduction or reduced envelope leakage, improved fenestration, better windows, going on. And then you get some really big credits for things like DOS, where like here for UA reduction, you might get at most 10 points. For a DOS system, you get 56 points, right? So with 56 points, would that get us close? Well, it would depend on the type of occupancy. So that'd get us about halfway, a little more than halfway there. Right, if we were to use a DOS system, so we might have to use DOS and something else. For example, service water heaters, like using heat pump water heaters, that gets you like 111 credits or something like that, or heat recovery. So they're trying to push you in different directions, design-wise, while still allowing flexibility. If you're like, you know what, heat pump water heaters make a lot of sense in Seattle, but not a lot of sense in Boise. So sure, I could get those credits, but you know, I want to be my own engineer, and that means, yeah, I'm going to focus on what I can control in terms of like reduced air leakage or UA reduction or more efficient mechanical equipment rather than having you know, a heat pump water heater. So the takeaways for today, I want to wrap up. Is consider performance modeling, particularly right now while it's easy in the 2018 and 2021, before you start getting into that percentage annual energy cost savings. Instead, just look for 15% cost reduction using an energy model. I think that's great for clients. It can simplify a lot of portions of the energy code, particularly in the mechanical section. In terms of the new credit system for 2024, I would recommend reviewing it. It's free online. Just Google IECC 2024 digital code and look through the section when you've got a new project. Even if you're on an older code cycle, even if you're not gonna, you know, you don't need to do this, I think it will help in terms of trying to set energy efficiency priorities. That's the goal of it. It's trying to show you what is the low-hanging fruit out there. That's the code's trying to push you towards designing towards what makes the most sense for that particular occupancy type and climate zone. Is it going to be right all the time? Absolutely not. But it might help you along the way. And so that's my homework for you guys, is just take a look at it, so it's less overwhelming and or concerning once you encounter it in real life. And it might just, yeah, give you some insight on what ASHRAE and IECC thinks are positive design decisions to make for different buildings in different climate zones. All right, I'm going to stop talking now. Any questions for y'all from y'all, aside from me checking my math? Thank you, John. If not, I can send out at the end of this CEUs. Those will probably come from Dylan Agnes at our office. And if you do have further questions, my email is here. It's just dwoods@uidaho. I, as a research professor, like we're given funds to try and help answer your questions. So if I don't get it right at first, then we will do our best to research and send the grad students off and get something back to you. So just remember that it's a free service. We're not here to compete with any consultants. If you are a consultant, we want to just help you do better. So if there's something you're curious about or want training on or are looking for like peer-reviewed studies that you don't have access to, because you're not subscribed to ASHRAE or something like that, let us know because we can go out and find that for you. So, anyway, I appreciate your time today and hope you have a good rest of the week. And maybe I'll see some of you tomorrow at the ASHRAE lecture.